welcome to AWS On Air. This is the show where we dive deep with service teams. Today we are here to talk about the launch of Graviton3 that was just announced in Adam's keynote this morning. I'm Jenna Pedersen. I'm a developer advocate here at AWS. I am joined by my colleague, Sebastian.
Sebastian, developer advocate at AWS as well.
And then our guest.
I'm Arthur Petit-Pierre. I'm a specialist SA looking after the Graviton-based instances. And so obviously Graviton3.
Excellent. So tell us high level, what launched?
Graviton3, it's the next generation Graviton after 1, 2, 3, but maybe let's start with what is Graviton?
So Graviton is a brand and a range of processors that have been in-house designed at AWS. So we've launched the first generation actually in 2018. That was with the A1 instances. And maybe you have not even noticed about them. A year later, here at reInvent in 2019, we have announced the second generation, the Graviton2, that I've been working on for the last 2 years. And today, we are announcing the third generation, the Graviton3. We are just doing the announcement. It's available as a preview today, but we will make it available next year.
So what are the advantages for me? I'm an application developer, I'm deploying, I don't know, Python, JavaScript, or maybe I'm running data analytics in the cloud. What type of advantage can I have by using Graviton3?
So the main reason why we have released custom processors is to make them available with a better level of performance and a lower cost. And that's the main reason for any developer to adopt those instances. They are cheaper and they are faster. Graviton2 is up to 40% better from a price performance standpoint, and Graviton3 is even faster and even better than Graviton2.
So I can get more work done for a lower price compared to the same generation or the previous generation of x64 type of computing.
That's exactly the goal.
What sort of customers can take advantage of this? Is this for anyone that wants better performance, or is it for specific workloads? What are we thinking here?
So Graviton2 is, Graviton in general, I'm still saying Graviton2 all the time, and Graviton3 is so new. But Graviton in general is a general purpose processor.
Okay.
So it means that you can apply it to many different kinds of workloads.
Okay.
From web servers, gaming servers, databases. It's really good for in-memory databases because the memory latency is really low. Storage, whatever application you can throw at it, it's going to be pretty good.
Okay, excellent.
But Graviton processors are based, it's a different architecture. It's not the traditional x64 processor architecture that we know since like more than 20 years. It's ARM based. So what does that mean to actually deploy existing application to an ARM processor? Do I need to recompile everything?
Sure, that's a really good question. And that's even a better question because people might have in mind the difficult migration that you had in the past when you're migrating, for example, from proprietary operating system on
processor.
Power
I used to work a lot
with. You're moving to Linux and x86 at the same time, and you were changing everything while doing such a migration. The APIs with the operating system were different. The processor itself was vastly different. And so that was painful. You had to rewrite significant chunks of the application. When moving from Linux on x86 to Linux on Graviton, that's a way easier migration. You're staying with the same operating system, so you don't have to change the APIs that your application is using with regards to the operating system. And from a processor standpoint, there are differences at the low level, but all the things that applications are doing at a pretty high level remain completely unchanged. So
it's the same Linux, same Java, same Python?
From a Linux standpoint, you can use the same distributions. So for example, Amazon Linux is available for both x86 and Graviton-based instances. Same thing is going to be true for Ubuntu, Red Hat, SUSE, they're all available and support Graviton-based instances really well. However, there are different versions. There's one for x86 and then one for ARM64. From an application standpoint, if you're high level, usually you don't have anything to change. If you're using Java, the bytecode for a Java application is architecture independent. So the only thing you have to change is the underlying operating system and use the ARM64 version and use the ARM64 version of the JVM.
So if I understand you well, for the vast majority of applications, you don't need to change a single line of code. Everything which is written in higher level programming languages, Python, JavaScript, TypeScript, Java, and the like. So what are the applications that we need to change, actually?
So when it becomes slightly harder is that when you have applications that are written in lower level languages.
Like C, C++.
Rust, even Golang. Those ones, you will have to recompile the application and potentially the dependencies of those applications. It tends to be pretty straightforward. If I take an example, our customer Epic Games, they have migrated one of their main gaming engine from x86 to Graviton-based instances.
And so these gaming engines are written in low-level programming languages?
C++, highly optimized.
Oh.
So that millions of lines of code.
Yep.
Okay. So that's probably the worst case scenario to migrate
that's
to
a difficult
ARM.
case.
Yeah.
Those guys are just amazing developers. So, well, they're able to do that really quick. But in this specific case, they've been able to do it in roughly a week to get the first version compiled.
Wow.
So you have a couple million lines of C++ highly optimized for x86, and a week after, with a couple engineers, you have something that is already working. Okay, then they've done some additional optimization to really benefit from Graviton, but if they are able to do that for such a massive amount of C++ highly optimized, well, chances are that most of our customers can do that too, and can do that in a really reasonable amount of time, even for those low-level applications.
So you mentioned this has better performance. Can you talk about that? What are the benchmarks here?
So there are many ways that a processor has an influence on performance.
Okay.
There's the way it will handle integer operations. There's the way it's handling the memory and the latency it has with the memory. And depending on the benchmark you're using, you're going to stress different part of the processor.
Okay.
So if we look at Graviton3 vs Graviton2, and we will start disclosing more of the performance-related data in the coming weeks.
Yep.
The first figure you need to have in mind is that we tend to say that Graviton3 is going to be roughly 25% faster for compute-intensive workloads compared to Graviton2. And then there are specific cases.
Sure. Based on workload and how you're
based
using.
on workload.
Okay.
As an example, I was running this morning some tests with X264, which is an encoder for the H264 format.
Okay.
With that tool, given that we have vastly improved the vectorized operation on Graviton3 compared to Graviton2, we have a 50% increase in terms of performance when using those transcoding application on Graviton3 vs Graviton2.
Okay.
And well, you can expect significant performance improvement for many different applications actually.
Yep.
So one of the customer of Amazon EC2, it's AWS itself, with many services, database, Lambda running on underlying instances, because we talk about serverless, but let's face it, serverless is not without server. There is server somewhere. There are servers somewhere, and these are most of the time Amazon EC2 instances. So can you tell us about the other services that are leveraging Graviton processors and architecture right now, and where as a customer I can take advantage of Graviton without having to start my own EC2 instance? And
that's actually an interesting aspect of adopting Graviton. Uh, Adopting Graviton for EC2 instances always requires a little bit of work because you have to at least use a different version of the operating system. Managed services, on the contrary, the really cool thing about them is that you're using an API, a well-defined API to access them.
Like Lambda function, for example?
Lambda function, well, that's a little bit different because Lambda function, that's still
bad example.
a compute
database
related, but accessing a database.
Yeah.
Whether your Postgres database runs on a Graviton-based instances or an x86-based instance, the API it presents to your application is the same.
Yeah, as an application developer, I don't really care on what type of system the database is running.
Somehow you still care because we have released those services for the latest versions of the underlying engines. So for example, if you're using MySQL 5, well, sorry, we've only released it for MySQL 8 on top of Graviton-based instances. So you have to first upgrade your application to use MySQL 8, and then once you're there, you can move from x86 to Graviton. If you're already at 8, then you can switch. You can even do that. I was about to say in production, please don't do that. But in a test environment, you can add a read replica on Graviton transparently to an already running x86 RDS instance, get the data replicated, start testing your application against the read replica, and when you're fine with that, promote the replica to being the main one, and go with it. We have a blog post documenting that.
So database is one of the services where I can take advantage of a better price-performance ratio.
Sure.
I think containers as well for ECS or EKS. I saw something last week.
EKS, that's definitely just a variation on top of running on EC2 because EKS, that's the orchestration layer.
Fargate.
Fargate has been announced this week for ECS. EKS is going to come later.
And Lambda has been announced last week.
Lambda, that was almost 2 weeks ago now. And Lambda is really a good opportunity. You directly get a strong cost reduction and better performance. And for most of the Lambda functions that are written in high-level languages like Java, PHP, Node.js,
Python,
they would just run transparently on top of Graviton-based instances.
Wow. So it's not only on EC2 instances that I start, but many of the managed services from AWS are also leveraging the Graviton architecture, and I guess more and more will be added over time.
Among the managed services, we have released RDS for MySQL and Postgres. We have released Aurora. We have released Elasticache for both Redis and Memcache. We have released EMR. We have released OpenSearch. I might be missing a couple.
Lambda,
the list starts to be long. EMR is also
EMR,
available.
I was talking with a French customer last week that told me they just changed one line in their CloudFormation templates and redeploy a cluster, an EMR cluster on Graviton2, because last week Graviton3 did not exist yet, officially.
Yeah, sure.
And they observed that 40% price reduction on there. And that was one line of one line changing in their code only. ARM processors are very common on phones as well because of the low energy consumption. So what is the impact of switching to Graviton 2 and now Graviton 3 in terms of green IT, ecology, and power consumption?
So Graviton 2, we already mentioned that it is up to 3.5 more energy efficient than an equivalent x86 processor, and we are here talking about the power consumption at the processor level. For Graviton 3, we have measured that Graviton 3 based instances are up to 60% more energy efficient than equivalent x86 based instances.
Wow.
So that's a significant improvement.
So by choosing Graviton 2 or 3, not only I do good things for my credit card, but I also do a good thing for the planet.
Yeah, you would even do a better thing if you were optimizing your application on top of using a greener instance. But yeah, definitely.
That's super important. the responsibility of the developer to use less CPU cycle, to consume less CPU cycle, lower memory as well.
And that's a cool part of our job, helping thousands of customers to adopt Graviton-based instances. Since we're doing a migration from one architecture to another, that's a good time to talk about performance and to talk about how to improve the performance of application. And we've seen many customers who, when adopting it, not only have benefited from the better performance from the processor itself, but they took the time to dig a little bit into the performance details of their application and took advantage of that to optimize their application so that they were winning on both sides.
On both sides, yeah. So you said that Graviton3, so that's the new C7g instance, are available in preview now. Do you know the regions where it's available?
So they're available in preview in 2 regions, US East 1 and US West 2, so North Virginia and Portland.
Okay.
You can apply to the preview. There's a link. If you look at the blog post from Jeff Barr on C7g, there's a link to the preview. So you can use it, register your company to get access to those. The only thing you can't do is use those for production workload, but it's a good opportunity to test the performance of your application, to let us know what you have seen, whether you've seen any issue, whether you've seen wonderful performance improvement. That's what I expect.
What's the best way for people to submit that feedback?
So when doing the preview, we will give them contacts to reach out to us, submit any problem that they might find, and to report good and bad experience so that we could improve everything.
Excellent.
Okay. I have one stupid question. No, it's not a stupid question.
No questions are stupid.
No, but it's something I heard a lot from developers saying, okay, I have already instance running. I don't want. Can I just stop my instance, change the instance type, and restart, and it will work?
Maybe.
In some cases, almost. That would be nice. Not exactly, because you can't take an existing AMI, which would be what you would have on a running instance, and move that over to Graviton. Where you can almost do that is when you have a containerized workflow.
Yes.
Because if you are running your application in a container, then the only thing you have is rebuild your container for the ARM64 architecture, push that to your repository, and there's that nice feature which is called multi-architecture support for containers. So you can build actually 2 versions of the container and upload that under the same tag, use a mechanism called manifest lists, and there's a reference to the 2 images, and then you just need to reconfigure your ECS cluster or your EKS cluster to add Graviton-based instances, and as soon as you will start to schedule tasks to those instances, it will pull the ARM64 version, and you will kind of transparently move from one to the other.
So it's possible using containers.
Yeah.
It's doable. Thank you very much. That was super clear to me.
Yeah. Other than checking out the preview, is there anything else that customers should know, or how they can get started?
That's a good last call.
Yeah.
One thing that you should really have a look to is we have a Graviton Getting Started guide on GitHub. That's where we push all the information to make developers' life easier.
Yep.
So we update it constantly. People who have to recompile an application, that's where you can find the specific flags that will give you the best performance on Graviton. You will find a list of ISVs that have ported their application. By the way, you might have noticed yesterday that we announced the Graviton Ready program for ISVs. So as an ISV, you can get into the program and get recognized for that.
So how can I find that resource guide? I just use my favorite search engine and I type AWS Graviton, getting started,
and you will find the GitHub page.
All right.
Great.
Well, thank you so much, Arthur.
You're welcome.
It's been great having you here today. And this is the end of our show. Check back in just a little bit, and we will have another launch to talk about. Bye-bye now.